Alrighty. Hello, everybody. I'm sure Dave's still going a little bit longer, so we might have some stragglers coming in. But I'm going to just start out today for our panel discussion on integrating smart hydronics. My name is Leah Den Hartog. I am the editor of Plumbing and HVAC magazine, and I will be your moderator for today's session. I'm going to let each of our speakers today introduce themselves, and if they could, please just answer the question as to how you work within the hydronic controls market. So, Bo, do you want to start?
Sure. Hi, everybody. Thanks for attending today. My name is Bo DeAngelo. I'm the manager of technical services for Anisi gas heat pumps, and we use our systems in hydronic applications quite a bit. And so I find myself designing and specifying the control systems that we use for both residential and commercial hydronic applications.
All right. Good day, everyone. My name is Jay Vath. I'm a applications and systems engineer at Tekmar Control Systems. And Tekmar is a manufacturer of electronic controls for the hydronics industry. So that includes radiant floor heating, snow melting, and controllers for light commercial applications.
Jeremy?
Yeah, my name is Jeremy Young. Thanks for joining everybody today. I'm the mechanical sales manager for Pro West Sales in British Columbia, Canada. We're a manufacturer's agent for a variety of hydronics manufacturers. And I'm also an instructor at TECA, which is the Thermal Environmental Comfort Association. And I teach a couple of their courses there on hydronics, both hydronic heat pumps as well as hydronic design.
Thank you, Jeremy. Dave, thanks for joining. I know you just came a little bit late because you've already been running another hour. So I appreciate you taking another hour of your day to join in on our panel discussion. So I'm letting everybody on the panel here just introduce themselves. And if you could just explain how you work within the hydronic controls market, that would be wonderful.
All right. So Dave Holdorf here. I am the Eastern Region Training Manager for TACO, meaning half of North America. East Coast wise, not just the coast anymore. But anyways, so I do the product and applications instructor for everything that goes in a box for TACO. So which means I can carry it with one hand. If I can't carry it in one hand, I don't do training on it. I have another group of guys that does the big stuff out there. So when it comes to hydronics, that's been my career for the last 30 years. Started off in the PEX world, tech support and design on radiant floor heating. If we think about, in the mid 90s and learning about radiant, which was scary back then to a lot of people. And, hey, how do you get the air to go down that pipe? Okay, move along, son. We've got other people here. So is some of the early stuff that I did. And now here at TACO, taking care of the residential side of training. So, and controls wise, obviously, lots of controls on the TACO side too.
Wonderful. All right. Thank you, gentlemen, each of you guys for joining today. So I have a list of questions I'm going to run through today. If anybody has questions sitting in the audience, feel free to ask. Panelists, if you guys want to ask each other questions, I also encourage that too. Today, I'm just kind of leading the discussion and making sure we land in the 55 minutes we have left. So to start out, I kind of wanted to start out with a generalization question. Let's talk about controls in a wide space. So the question I want to start with was, controls with hydronics could mean a variety of products within the system. What would you say are some of the components that can fall under this category? Somebody want to jump in?
Sure, I'll kind of start this off. I mean, generally speaking, you've got, I'm going to start by framing it. I'm going to focus on residential kind of space heating applications, because hydronics can also be industrial, can be commercial, but we're talking about the end use, right? So everything from the thermostat, looking for comfort at the person, back to zone controls, which could include circulators or valves, priority controls for various different tasks, trying to prioritize loads over each other, like domestic hot water, for example. Could be outdoor reset, could be staging. There's a lot of different places for controls in hydronics. And, really, they need to be a concept more than anything. They need to be a big part of your design early in the design phase, even before you start piping things. They're a very underappreciated part of the industry.
Does anybody else have anything they'd like to add on to that?
I would, look at the thermostat. Probably the most powerful piece of equipment that we can put in somebody's home. And the reason why I say that is because the reason why we see more, and how many zones is normal today in a house, right? There is no such thing as normal. And what ends up happening is that the thermostat becomes so powerful because it's the only interface to what goes on downstairs in the basement. And I'm sure all of us here have gotten a phone call from a customer and says, hey, can you come over and take a look at my furnace? And you go downstairs and you're looking at a boiler. Okay. So remember how powerful that piece of equipment is that you have out there. So yes, homeowners want to have more and more zones because they don't know what we do downstairs. So that's their control. All right. That thing is the control in the whole house, so to speak. Right. So making sure that, yes, as Jeremy was saying, we're comfortable in all parts of the house themselves, not just where the thermostat is. So that's why we start seeing more and more zones out there. Definitely.
Yeah, and I would expand upon that as well. Like I know everybody on this call is probably more mechanically focused, but the mobile apps are actually part of your control system now. And for a lot of people, that is their user interface point for their heating and cooling system. So whether it's a phone or an iPad, etc., that becomes the way that the homeowner sees their HVAC system. And I completely agree with Dave. Like, homeowners are scared of mechanical rooms. They're very reluctant to even open the door. And even the ones that do venture in, they are very nervous. So, even getting them to take a photograph of a controller with a flashing light or something is, let's just say they're reluctant to do so.
I'm at the age now that I have a lot of friends that are buying their first home. And I'm always now the weirdo that goes, can I see your mechanical room? And every single one of them hates that question because they know I'm going to start taking pictures of all of their mechanical room stuff. And it always makes me laugh. But yes, they have no clue. To Dave's point earlier, too, I had a friend who just bought a house and she was telling me about her heat pump. And I was like, oh, no, honey, you have a forced air furnace. And she's like, oh, I had no clue. I was like, I know. But to go back on a little bit of track, Jeremy, you said in your first answer there, talking about controls, all of the different elements in it, you mentioned it as a concept, and I really liked that term when we're talking about hydronic controls. Can you walk me through a little bit of what an effective concept of hydronic controls could look like, and I think somebody mentioned earlier in this call, we are going to focus today on residential. So we can mention once in a while other elements of it, but today for the most part, our conversation is going to be about residential. So Jeremy, could you expand a little bit on this, concept when we're talking to hydronic controls?
Absolutely. So I always like to think starting from the person, right? That end user probably just sees a thing on the wall that they occasionally touch, but ultimately we're starting with comfort. And this could also be from a sensor for a snow melt system or an aquastat in a domestic hot water tank, for instance. But the signal starts at the load, essentially. It's going to work its way back from there. So then it's going to go to some kind of a controller, potentially for zoning, if you have zoning, which could be valves or circulators. So you're starting circulators, the right ones for the right load, because there can be systems with multiple temperatures with mixing valves and things like that. So you want to make sure you have the right circulator running for that zone, and then enabling your heat source, whatever that may be. In hydronics, it's not like forced air where you have a call for heat and immediately that furnace or your friend's heat pump is turning on. We're responding to target water temperatures. So I always like to convey hydronics like a conveyor belt of heat. You put heat on the water at the beginning, and it's got to be carried by that water down to the finish line. But just because there's a call for heat doesn't necessarily mean the appliance needs to turn on. And this gets really more prevalent in systems with buffer tanks or higher mass heat sources, where there's a lot of thermal storage of energy in the appliance. It may not actually need to turn the appliance on. You may be able to deliver some reserve heat from something quite easily. So as long as that sequence is being followed, thermostat to zone controller to circulator to something analyzing the water temperature target, which could be the appliance itself. In a lot of simple systems today, it is. But it could be something more centralized, especially in like dual fuel systems. I see today a lot of appliances that have a lot of simple systems built in, like say outdoor reset built into a boiler. But if you take an air to water heat pump and a condensing gas boiler that both have outdoor reset built into them, and you have another staging control that has its own outdoor reset algorithm, you really have to have a good understanding of which one of those things needs to be the boss of the system, which one is the overarching controller of everything, and make sure there's no conflict between all your different set points. So you can get yourself into the weeds quickly by having overlapping control from multiple devices that actually might create more problems than helping. But once your set point is hit, plus or minus your differential, your appliance is going to turn off, which may or may not be the same time that your circulation stops. There's usually some post-purge sequences and things to circulators. So, it's going to sort of roll back in the opposite order it started with. So if it starts with the thermostat to the zone controller to the appliance, targeting a set point, then it's going to stop the appliance first, then your circulation, then back to the thermostat.
Thank you very much, Jeremy. Does anybody else want to add anything?
Yeah, I think, just to kind of go back to Jeremy's point about concepts, I think probably one of the things that really is very important, particularly with residential hydronic controls, especially if we're talking about radiant floor heating systems or just radiant systems in general, is all the way back to the design and also working with the homeowner, contractor, architect, or whoever the design team is in the process. And of course, the homeowner always is going to have a say in that, really understanding what the objective is for the thermal comfort of the envelope. And what I often see, having designed thousands, literally, of radiant floor heating systems in my career, is that quite often when it's left to the homeowner or left to the architect or builder, the system is poorly zoned or not strategically zoned. And one thing I will say is that in a radiant heating system, rule of thumb, you really can't have enough zones because you have so much control over that system. And there can be such a difference between, say, one room and another, literally over the threshold of the door, between the actual, sensible comfort of the space. And so it's really important to understand what that zoning strategy is. So all the way back at the design phase, when I'm looking at a project for how I'm going to control it, I'm thinking about how the building is going to be used, having a conversation with the building owner or whoever's involved, and really getting a good understanding of how they want to control it and what level of comfort they want. Because in most cases, I'll have a home with every room being its own controlled zone. And often that is something that is missed. And, I've seen radiant homes that are quite large with 3 zones of heating in them, which will be a miserable building to live in, especially in the shoulder season. So it's really important to understand what the objective is for thermal comfort and then design the control system to deliver that thermal comfort rather than try and fix it with controls later, which I know three of you guys know is a much more complicated undertaking than doing it right in the first place. So I think that's probably one of the biggest components, is really understanding what that is. And I think a lot of people just really don't understand, especially when it comes to those systems, even hydronic systems, even just a multi-zone hydronic baseboard system should be zoned in a smart way. Your recovery is going to be a lot faster. Your cool off is going to be a lot faster. So it's a little more forgiving. You don't have that forgiving nature in radiant floor systems for sure.
Yeah, I would just like to add that, it's very important to know who your customer is and what's important to them. So I agree with Bo. It's not always comfort. I've had, especially mechanical engineers, they're very focused on efficiency, or maybe it's decarbonization or some other motivating factor. So learning what's important to your customer and then trying to design the system to accommodate their what they feel is important is essential to being successful.
That is a great segue. I love this. Thanks, gentlemen. We did not plan this. So first, I want to relate back to the chat. So first, Brian, I haven't forgot about you. He mentions when we first started talking about the mechanical room, he said instead of calling it a mechanical room, it makes eyes glaze over. Call it an ice room, which generates interest, especially knowing more comfort equipment. So I quite like that. That's a very good little tidbit, Brian. And it's a nice segue. I didn't even tell him to write that question for what I'm going to ask the panelists next, which is, what would you say are some of the suggestions you'd give installers regarding communicating with homeowners in relation to their hydronic controls? Because I know how complicated hydronic controls can get. And I know every single installer will absolutely hate the homeowner that wants to touch the control, any of the types of controls, and screw up the system design. So how would you say are some, or sorry, let me rephrase that. What would you say are some of the suggestions you would give to installers communicating with their homeowners, their customers?
If I were training my installers to, engage with customers on how they want a control system, I think probably the first thing I would try to instill in the installers is that in most cases, the simplest approach is always the best. You can really get quite complicated with controls. And so simplifying the system as much as possible to achieve the objective, which is what, the customer wants, is thermal comfort and potentially efficiency and so forth. And all of those things really should come together. I mean, we should drive thermal comfort at the least possible expense of energy, I think, is probably a good place to start, with the least amount of legacy and complication in the control system. So that's the first thing. And then try and really listen and understand what the customer wants, but also not be afraid to make suggestions to the customer after they've listened to the customer and fully understood what the objective is, and then work with the customer so they understand how their objective can be met with the design and or approach to controlling the system.
Yep. I like make it simple, but don't make it simplistic. All right. That's, I think we also run into that often in a lot of installs. And when it comes to talking controls with homeowners, I find a lot of us, we talk to homeowners how we would talk to each other about our products and what's going in and the design of it and whatnot. And that's also when they start to glaze over. All right. I call it hinge neck syndrome. Yep. They're just shaking their head, agreeing with you, but they're actually thinking in their heads, I hope he leaves my house soon. So type of thing. So we end up talking to them in our speak. We don't talk to them in their speak. And we need to give it to them in words that they understand. So when we start talking, for example, outdoor reset, which was dropped a couple of times already here, right? And I know everybody here understands what that is, but does a homeowner know what that memeans? And all of a sudden you start saying, well, yeah, it's going to get warmer outside and the water's going to get cooler. Wait, what? You're sending cold water to my house? I thought this was a heating system. So we start talking about it. And then the reset ratio. Oh, forget about the reset ratio that you want to program into the controller. So that's, I think, a downfall that we also have in our industry. Talk to them in what you're doing, but in their speak as well. So when it comes to outdoor reset, I say, think of cruise control in the car. And why do we have cruise control? It's all about fuel economy. Because now you say the word fuel economy or economy of operation or economy of scale, and it's just like, oh, okay, all right, and but again, explain to their terms, keep it simple, don't make it simplistic, and the words you never ever want to hear once you finish an install and you've got all these pumps, controls, valves, everything all over the wall here. That's our artwork. The homeowner looks at it and says, you better never die, because no one's going to figure out what you did. Could be job security, but yeah, exactly. At the same time. Yeah.
So like hydronic systems, they're often like 2 to 3 times more expensive than a forced air system. So when you're selling hydronics, you're really appealing to how people like, hey, this is going to make you feel better, or you're not going to feel like you're too hot and too cold all the time like you do with forced air. So you're actually selling a vision or a dream of like you're feeling comfortable all the time. And so rather than getting wrapped up into the technical details about like these are pumps and we have water in the tubing, you're selling an experience more. And because of that, it's like you're appealing to more of a premium customer base, and you're selling a more higher ticket item. And so my advice would be sell the dream of like you're selling comfort to your customers.
Sell the dream. I like that.
I have selling a vision and selling an experience written down here. I like both of them.
Yeah.
Anybody else want to add anything? It's okay if we don't.
Covered pretty well already. Yeah, just understanding what
I
the
think we have.
homeowner wants.
I just want to make sure. I know Zoom calls. I know these kind of calls. It's hard sometimes to jump in, so I just want to make sure everybody feels that they have a comfortable time to be able to answer. I'm gonna also jump back to the chat and just say Michael's suggestion is document and label everything.
Yeah, one thing that I would also mention is if you are dealing with like custom homeowners, like custom residential homes builders, there may be architects or interior designers that are involved with the project. And not only does it have to functionally work, but does it look nice is also important. So, you know, in some systems, they don't want to see thermostats on the wall. In certain systems, you know, want to have like a certain aesthetic, like maybe the towel warmers in the in bathrooms, etc. So know who you're working with to sell the system.
Still in the chat, Brian writes, picture equals 1,000 words. All of us, clients included, understand concept diagrams better than talk.
Yeah, I think that's essential to any complicated mechanical system, to leave behind wiring diagrams, piping schematics, some kind of clear understanding of the sequence of operation of a system, because, you know, to Dave's point, the person who came up with the idea may not be around or available when you need some help. I've actually seen, you know, systems that were not executed in the cleanest way, I'm trying to be polite, affect resale value of homes, because someone's looking at the house as a cost of ownership, and they open that door and go, oh my God, I wish I didn't open that door. I have no idea what that is, but it looks like a cost that I don't understand and I don't know, right? But you can present a system in a clean way with, you know, it doesn't have to have LED lighting and, you know, smoke machines and stuff. It can just be a nice plumb system that's tidy, that's serviceable, with some good documentation on how to get it working on Christmas Eve, and that can go a long way.
Okay. The next question. So we've talked a bit about smart thermostats now a few times in some of our questions here. So I want to dive a little bit more into the into the world of smart thermostats. So what should be considered when deciding which thermostat would work within the system?
I mean, it's a lot of radiant floor systems, if I'm going to make a generalization, are heating only, although that, you know, it's going to change by region, of course. But integration with ventilation and cooling will be a part of that. And then how complex the system is. When I ultimately talk to somebody about Wi-Fi thermostats, I'll see Wi-Fi is not the same as smart, but just to start narrowing it down a bit, ultimately the homeowner is looking for control of the temperature in the room. And that might be coming from a background of systems that respond faster than a high mass radiant floor. So, you know, the idea that you're going to be able to drop the temperature while you're at work and have it back up to set point again by the time you get home is not really practical in a high mass system. It can actually hinder performance, comfort, efficiency, everything. So understanding why they're asking for that is important. There's a lot of, say, boilers today that have Wi-Fi built into them, and that's often misunderstood to think that, oh, well, the boiler has Wi-Fi, I can now change all the temperatures in the rooms. No, you can just see that the boiler's running, but you don't know. All you can see is the temperature leaving the boiler. You don't really know what's happening after that. So depending on the scale, that might be acceptable, but more often than not, I find trying to get reliable Wi-Fi connectivity at every thermostat location in a heavily zoned system is a disaster waiting to happen. I mean, with a homeowner with a smartphone can just walk to the next room if their streaming is lagging or something, but the thermostat's stuck there. So having some kind of a networked system with a single connection point to the internet or to a home automation system seems to be a lot more reliable in that sense. When you start getting into things like wireless thermostats, which tend to be the kind of thing that happens when the drywaller got there before the wiring guy did. It's more of an afterthought, of a problem-solving thing than a design intention, although some of that's changing with new technologies. But wireless also has connectivity challenges, usually involves batteries, which, on a large scale might need a large quantity of battery replacement. And, if a home's unoccupied for large portions of the year, that might not be the best fit. If you're at your summer home and your house is freezing because you didn't swap out the AA's, that's a tough day. Right?
I think that today consumers are starting to become desensitized to smart appliances and Wi-Fi enabled equipment and so forth. And that's simply because, today you can buy a new washing machine and a cooktop and a refrigerator that all connect to your Wi-Fi network, which I'm still trying to figure out why I would need that. I have yet to come up with a reason. I still really can't think of a good reason to connect my thermostat to Wi-Fi short of, changing my internal set point if I'm on vacation. And I think you're going to find, I think contractors probably would agree to this, that customers want maybe some level of connectivity, but they don't necessarily need everything connected. They don't need to do all this information. They just want general information. My heat isn't achieving set point, which is a common response from, say, a smart thermostat. Your system's been running for 2 hours and it's not achieving set point. Something like that might indicate a problem. That's really good information to know. But how many times your system cycled in an hour is probably not relevant information to a customer. And having the ability to change set points or setback in zones. I mean, you have 9 zones. I live in a 2,500 square foot house with 10 zones of radiant floor heating. So that's a lot of zones for a small square footage. I don't need 10 thermostats talking to me. I need one change of my outdoor reset curve to put my building into setback, and that's all I need. So, and that will drive really good thermal comfort. So at the time that I want it. So I think that people are becoming a little bit more desensitized to that. And I know that particularly on our systems where we have both hydronic systems that are multiple zones of various different emitters, and also hydro-air systems, which are hydronic systems that are delivering heated water to a hydronic fan coil where we're delivering heat through air through the home. In those cases, smart thermostats, and I'm not going to name any names, but you all know who they are, in some cases are really good, and some of them are actually really bad because they have internal algorithms that try and determine what the best operational strategy is as far as energy savings through their own logic. And sometimes that will fight with the manufacturer's equipment or the manufacturer's intended control logic for how the system is supposed to operate, and can actually create an adverse effect of short cycling, which is what definitely do not want to have in any piece of thermal comfort equipment. So I think there's some adaptation that needs to come. I think more setting capability at the installer level for these types of smart thermostats is necessary. I've talked to many manufacturers that offer that level of in-depth control into the back end of the thermostat, which, at the end of the day, a thermostat is simply a limit. It's a room limit. It's designed to stop a space from overheating. If your design is done properly, the thermostat should never stop calling. And so that's really not the case with smart thermostats. They'll try and start and stop the system. So having those manufacturers start to adapt to that and listen to those installer demands or contractor demands of what's necessary in the industry is also going to be an important transition for more of these smart appliances or control systems as they come online.
I'd like to just add quickly that most smart thermostats on the market are actually designed for forced air systems. So they're not really well suited for hydronics. And you'll actually find that, like Bo was alluding to, equipment that has outdoor reset, and then you have like a thermostat designed for forced air, you're going to result in a lot of weird cycling, and you're actually going to reduce the comfort level in your home. So there are products designed specifically for hydronics, and those products will work better together with outdoor reset. Other things to look at for smart thermostats would be ease of usability. So a lot of smart thermostats also come with colored touchscreens, which make it easier to understand how to set up programmable schedules. Often the mobile apps make it also easy to set up programmable schedules, and just like your typical your mode and your temperature adjustments that you would make on a thermostat. So I'd say like the usability of the products that are considered to be smart to be easier than the non-smart thermostat offering.
I'm gonna tell a story that happened to me. So a couple of lives ago, and working with some controls, and we had an advanced control platform that put the entire mechanical room online. So you could see pumps that are on, I could see target temperature, actual temperatures, boilers firing, all this information, which was freaking awesome. All right. $20,000 control platform dropped into somebody's home. And what did they want? The homeowners? They wanted a Wi-Fi stat. Right. So again, listening to what, it was cool to me. I put it in my own house. Of course, I'm like, I got it. It was great knowing everything about my entire boiler room whenever I wanted to. But again, it's what's the homeowners looking for? What do they need on our Internet of Things and everything talking online? If they just, again, and I remember seeing a lot of data. Yeah, we got all these Wi-Fi style thermostats, and everybody assumes, well, the homeowner wants it, so this way I can look at it whenever I want on my phone. And that happens a lot the first 3 months. And after that, maybe once a year when they take off and they go, oh, I forgot to set back the thermostat on vacation. Right. So so they want it to be that smart capabilities. And I think we have the difference between smart, as we've talked about already here today, where it's smart for the systems and the heat delivery into the house itself, but it's also Wi-Fi doesn't mean it's smart either. Right. Mm-hmm. Wi-Fi just means it's connected. Right. So, again, what do we want it to do? And again, 10% of homes are hydronic. 90% is forced air. All right. And a thermostat manufacturer, that's what you're going to focus on. Right. You're going to focus on 90%, not the 10%. So when you've got that system in the house, make sure it's set up for the proper heat delivery into the house itself. Yeah.
So we have a lot of clientele they actually have second homes, right? So I would say that monitoring and controlling homes remotely for some customers is actually really important. So the ability to be like, you look at it and you're like, yeah, I know that my second home isn't freezing, or that the relative humidity isn't high, or maybe I know that there's no water leaking in my home. That peace of mind is very important for that customer. And so like that aspect of smart devices is very important for that type of customer.
Alrighty. I want to jump back to the chat again, and I'm going to mention to Brian, Jay, you're going to like this comment. So to maximize hydronic system comfort, temperature of the flowing water is key. Tekmar House Control and Tekmar Net produces the best results that I am aware of. Outdoor Reset is a feed-forward control mechanism. Tekmar uses Outdoor Reset, but really shines with Room Response, which is a feedback control mechanism that scans all of the zones that are integrated and synchronized. And then I'm going to go on to the next comment, which is by Elaine. Any words on the links to energy suppliers who have access to thermostat so you do not use during peak hours and save money? Who'd like to jump on that question?
Okay, so like this is an emerging space here, but like demand response that integrates to electrical utilities is a feature. available on some smart products. And usually you sign up through your utility, and then they have a list of like products that their utility program is compatible with, and through that you can then select a particular brand of thermostat. So I know that there's links, like if you're looking for links, I would actually encourage you to go through your electrical or gas utility for that information, because you could actually purchase a product that doesn't have any programs in your local area.
All right, thank you, Jay.
Ultimately, something like that, in order to save you money, is going to be switching to another fuel type during those peak times, or storing energy some way, somehow during the non-peak times. So it's not just as simple as not heating the house when it's expensive to do so, right? There's got to be, what's the alternative? Because not heating the house isn't an option, right? So, for a conventional, all electric or all gas system without thermal storage of some kind, there's not going to be a lot you could really do with that information ultimately, except try to design a really energy efficient system from the get-go.
I think a lot of those style thermostats are also leaning towards the air conditioning side, right, on that peak consumption. So this way it obviously you should not be messing with the heating system, especially the large demand is, hey, when it's getting cold outside, we can't be like you said, dropping the heat off in people's houses. It should be geared towards the AC side of things. So I would double check that too with that vendor and the software that's built into it. It's really starting to look at that electrical load and making sure we're not having to do brownouts and tripping people's equipment and hurting equipment too at the same time. So yeah, I don't, and yeah, I don't. I mean, do I have one in my house? No. But then again, nobody's. I've always got somebody home in my house, so I don't want it being raised temperatures. I've got elderly living in my home as well, so I wouldn't want all of a sudden the utility to come along and say, "Well, no, we're not going to cool your house anymore. All right, we're going to raise the temperature on you because we're going to assume that you're not home in the middle of the day, and because you just didn't want to touch your thermostat." So that's my personal opinion at that point. So
yeah, so there are some products out in the market now that will, especially with hydronic heat pumps. So we're talking air to water or water to water heat pumps. And those will have controllers that will operate like a backup fossil fuel boiler. And these products will have a time of use programmable schedule. So you can optimize it so that you're getting, heating at 2 cents per kilowatt hour in the middle of the night. And then it can switch over to gas, at the peak time of the day. So those products do exist. If people have questions on that, like there are things available that you can look up on the internet.
Thanks, Jay. We have about 21 minutes left, so I'm going to jump on to one of our next questions, because I have about 5 more questions I want circled, and hopefully we can get through as many of them as possible. So I wanted to talk about system requirements for controls. So for today's modern hydronic smart controls, what would you say are some of the most common system requirements?
The most common system requirements?
Yeah. Is it talking about voltage, things like that? Are we is it space requirements, anything along those lines?
Oh, okay. Well, I mean, historically, most heating equipment has been 120 volts for the equipment. Thermostats are usually 24 volts. With hydronic heat pumps, there's been a bit of a change. A lot of the equipment's coming from either Europe or Asia, and it's usually 230 volt. And so there is a bit of a change with electrical requirements with the switch over to heat pumps.
Okay.
So I would say that's something relatively new in the industry.
Okay.
Yeah, having a good handle on contactors and relays, how they work, how to properly apply them is really helpful when you're trying to integrate, say, a 230-volt control voltage with low voltage controls and other low voltage components.
Thank you. Okay, I'm going to jump back to the chat again. We have a question from Chris. So he's asking, can someone speak to dehumidification with radiant service cooling and then brackets and heating systems? Simple is an independent dehumidification system, but are there hydronic FA coil options?
Certainly, I've had hundreds of chilled water hydronic cooling systems that I've worked with, and as long as you're paying careful attention to your supply water temperatures, you can handle all of your latent loads in the home with a properly sized hydronic fan coil that's intended for chilled water cooling. And it's important to pay attention to things like water flow rates through those. They're typically higher for chilled water fan coils than they are for heating appliances, because you want to minimize the temperature change through the coil. So there's a really cold surface on the coil for proper dehumidification, not just the first section of the coil being cold. So talking like, 7 to 12 degree delta T instead of 20 to 30 kind of thing, if you want to get into some Fahrenheit numbers. But yeah, I tend to prefer that over dedicated dehumidification systems if I can, because if I'm talking about cooling, a big part of human comfort is the humidity, right? So strictly removing the sensible load is part of it, but human comfort also has a big effect from humidity. So something needs to take care of that latent load. That fan coil could be ductless, could be ducted. There's tons and tons of different formats on the market. There's high velocity systems and all kinds of different things that can shrink the ductwork and whatnot if that's a limitation. But a lot of it, even just the ductless ones, can be great for retrofits. I've seen a lot of people go from a gas boiler to an air to water heat pump system on a system that was intended for radiant floor heating. But suddenly the homeowner goes, what, heat pump? I have a heat pump. How do I get cooling? So, suddenly you can run some properly insulated with a vapor barrier lines up to a ductless high wall cassette that looks like something out of the mini split HVAC industry, but has chilled water running through it. Now that's in the primary bedroom and giving them some cooling in the summer. So, yeah.
Yeah, we recently installed some hydronic heating and cooling fan coils at our Tekmar facility here. Essentially, you're looking for equipment with really large surface areas so that you can get your heating and your cooling temperature, well, your heating temperature down and your cooling temperature up, if you will. And then all of those equipment would have like a condensate drain line as well for dealing with dehumidification. Anyways, hopefully that addresses the customer's question.
Yeah, I would, when we're looking at hydronic cooling, right, and heating for that matter too, I always look at hydronic heating. We want to lower the temperature as much as possible, right? So, diligent design is going to make sure you're designing around the water temperature, but keeping it as low as possible. And the cooling side as well, we want to make sure that we're designing and using as high a water temperature as possible. Okay, so I like to call it high temperature cooling, low temperature heating. So, and modulate both. So now you're not looking at thermostats, you're looking at sensors,
Mm-hmm.
all right, that are installed. So yeah, we use the term thermostat all the time, but it's a sensor, and it's going to have to be a more advanced control platform, because you're paying attention to the humidity in the space, pay attention to the dew point of the space, the target water temperatures, make sure we're not condensing any of that in the house in the cooling mode. And when you're looking at radiant cooling and other hydronic cooling sections that are out there, that's happening. And again, like Jeremy was saying, you got to watch that humidity in there. So, but make sure you're not dripping in the building. That makes it really difficult and challenging, and you'll piss off a lot of customers when there's wet floors. So, and they think there's a leak somewhere. Yeah. So no. So yeah, the controls does become really, really important then, and making sure the control has all of that data being tied in. It's looking at room temperature, target temperature, and then looking at water temperature and dew point and all that stuff in between. So, yeah.
So I would like to add that, like I saw a study recently from the U.S. National Home Builders Association that said 97% of new home constructions have heating and cooling in it. What this tells me is that if hydronics doesn't offer cooling, we're out. Okay, so the hydronics industry really needs to provide cooling options with chilled water fan coils with radiant floor cooling. And if we're not able to raise the bar and get into these more sophisticated applications, I'm sorry, but the hydronics industry isn't going to be competitive versus forced air, and our market share will just continue to decline. And so, I mean, radiant floor cooling is complicated. There are a number of industry companies that offer design packages. There's control solutions for it. I would recommend getting training on it before attempting it, but it definitely can be installed and is successful. And is this technology is actually common throughout Europe, and it's still emerging here in North America.
I'd like a little bit of a tag for our next presentation then too. Michael Riddler will be speaking on residential heating and cooling. So if anybody wants to learn specifically on a little bit more in detail on that topic, make sure you stay for the next hour after our panel discussion, and we'll be going a little bit more into detail with Michael Riddler. Does anybody else have anything else they'd like to add?
I think I'll just reinforce the idea that retrofitting an existing heating only hydronic system into a chilled water system is a bad idea. That, you know, every pipe and device that touches chilled water needs to be continuously insulated with a vapor barrier. If it's cold enough to dehumidify in the airstream, it's also cold enough to sweat in the walls of your house and other things like that. So as long as the system's been designed for it from the beginning, I mean, Jay's got a really good point. We're kind of losing out in a lot of ways to the forced air industry if we're not keeping up with what the end user is looking for, right? It's very easy to do once you have a good handle on it, but I always suggest with stuff like this to take it piece by piece, right? I give the same advice to people first doing hydronic heat pumps. Like, okay, do a heating only application first, get comfortable with it, add domestic hot water to it, you know, then start talking about cooling. Where I see a lot of systems fall down is by not thinking about seasonal loads that require heating that are going to overlap with your cooling. So say you've got a pool or domestic hot water, which is a year-round load. How are you going to prioritize that to make sure the house still stays cold in a heat wave, but the pool is heated, the domestic hot water tank is heated? Sometimes that involves careful strategies of priority with different appliances, maybe a fossil fuel or, you know, electric resistance appliance handling those heating loads while the heat pump is cooling. There's a lot of different ways to look at it. Single buffer tanks, multi-tank systems. There's a lot of different approaches, but think through that whole thing all the way around the year, because that's where I see the systems really start falling apart, is when it's not thought about year round. Everyone just kind of looks at the design conditions, like hottest day in the summer, coldest day in the winter. Perfect, I've got both of those covered. But what happens in September? You know, when it's cold in the morning and hot in the afternoon, what is your system doing? Is it wasting a lot of energy heating and cooling the same tank over and over with systems with buffer tanks? Or is it, you know, looking at the outdoor temperature, anticipating that, shifting that target tank temperature in anticipation of that changeover? Are there valves that are going to divert flow to a different tank, storing energy for cooling? There's a lot of things to consider there, but just a thought to consider if you're new to it.
We only have just over 10 minutes, so I hope this is enough time to get into this next topic I want to get into, which I think we can explore quite a bit. I wanted to talk a little bit about dual fuel. We have mentioned it a few times throughout our conversations today as well, but I'd like to get into a little bit more depth of it. So how much more complicated does controls get when we start to work within the dual fuel market?
I mean, it can vary from very basic, from just like having a single thermostat. Like for example, you could have a forced air furnace with like an air to air heat pump on a thermostat, and that's a very common application, dual fuel. You can do systems where you can have hydronic heat pumps with backup boilers, and there's various strategies there. You could have it so that the heat pumps are backed up by the boilers as supplemental heat. You can do operations where you're switching over based on what's called a balance point. And a balance point is just like an outdoor air temperature at which you're switching from electric heated heat pumps to fossil fuel backup boilers. And then there's other equipment that's using dual fuel programmable schedules. So as I spoke to earlier, you can have like a time of use schedule, and you can have for certain periods of the day heated electrically, and then switch to like fossil fuel at other times of the day. So you can go from like a very basic single thermostat system to very complex systems that can be residential or commercial.
Yeah, there's a lot of hydronic heat pumps today that have the ability to stage on another heat source when needed. I like to talk to the end user and figure out how important redundancy is, because ultimately, if there's a critical failure in that appliance, it also may not be able to turn that other appliance on for you. So having a third party control managing all that can sometimes be a better approach, especially if there's multiple heat pumps, multiple boilers, things like that. But I mean, I tend to just look at, is it an economical balance point we're looking at, or a thermal one like Jay was talking about, where every heat pump, its capacity changes as the source temperature changes. And if that's air source, then your heat pump is shrinking as it gets colder out. So there will be a point where in a lot of systems, the heat pump no longer has enough capacity for the load, but that doesn't necessarily mean that it's more economical to use fossil fuel. And this is going to be region dependent and equipment dependent, of course, but the economical balance point isn't necessarily the same as the thermal balance point. But there could also be comfort reasons for shifting more rapidly into a backup system, so like coming out of a setback or a large domestic hot water load. So I like controls that have some kind of PID logic in them, kind of like cruise control was mentioned earlier. You hit that hill and it takes over, and okay, we're not reaching set point fast enough. We need to initiate this next appliance. But hydronic heat pumps tend to be a little slower in response because they're generally lower capacity. So I don't like staging controls that are meant for identical appliances. Like a control that's just meant to go back and forth between two identical gas boilers is not what you want for a dual fuel system, because A, it might have a rotation feature in there that's turning on the gas burst, and that might not be the goal. But B, it might not be giving enough time for that first stage to actually reach set point before bringing on that second one. That might not be what you want, especially if it's, say, an electric boiler backup. I know you're talking dual fuel, but bringing that in.
I'd like to add one other thing about dual fuel. So a lot of people will have like backup generators, especially in more remote areas. But when you're sizing your backup generators, they're generally not sized to run heat pumps. And so one option would be to have like a controller that can be powered by like an uninterruptible power supply or backup generator. And then it can bring on backup fossil fuel boilers to heat the building. And generally the generators can be sized to run like the circulators, the controllers, and the boilers. And then while the utility power is offline, you're still heating the building. You wouldn't even notice that there's a power interruption in the building. And then once power's been restored, it would switch back over to using the like hydronic heat pumps for heating the building. So that's another interesting use case for dual fuel systems.
Right.
So one thing I would add is, and this is just a shameless plug, this is one of the reasons that we think that gas absorption heat pumps are so important to the industry right now, because we don't require that backup and they are very low power consumption at 120 volt. I mean, a gas absorption heat pump that can handle a fairly large home is going to draw about 700 to 800 watts while in operation. So they're very, very low power consumption. And so we still do employ hydronic boilers, especially if we have a scenario where we have to our capability of the system before we start to degrade our COP. And so we will often integrate a hydronic boiler downstream if that is required in that system. And our system controls have already been designed to handle that capability. So we don't push our system into a forced lockout. It's actually a controlled shutdown. Because return temperature is exceeding a point where we want to see coming back to the equipment. So, but that's another reason that some of this technology is expanding in that direction. So, we talk about different technologies here, and there are different strategies to controlling that and dealing with those issues, especially where you have to have an uninterrupted power supply or a backup generator or something like that. This is where these types of systems start to come into play. And these are all air to water heat pumps that I'm talking about. So.
Thanks, Bo.
Yep.
Anything else anybody wants to add?
The controls obviously can do a lot. So when you are dropping a system in there, is it going to make intelligent decisions? No, we still have that control over, right? They're not that smart. So when we start looking at what outside air temperature this piece of equipment's running to that one, looking at the dead band in between, or sometimes it's as simple, and it's how common it is out there. I was just thinking about this at my in-laws' place, which is hydronically heated, and they have a mini split system heat pump for their air conditioning. And the way it's installed is it's two separate thermostats on the wall, right? So now you've got homeowners that have to know which one to touch. All right. Now the heat pump obviously can do heating in the house as well. So now it's, and unfortunately, the people that touch the thermostat is me. They don't do it. So, Dave, I'm too hot in here. All right. And I have to go turn the air conditioning on for them. It says, oh, no, it's not that thermostat anymore. It's this thermostat. So that's how their house is right now. Yes, I would love to add other controls to the project to make it easier for them to live. And then it's that decision making that the controls downstairs have to make exactly, what piece of equipment to run based upon what's going on. So you can go real simple, and you can go as complicated as you can right now. Yeah.
Thanks, Dave. All right. Any other additions or anything? We have like an uncomfortable minute and a half left on the time, which is absolutely not enough time for us to get to any other questions. So one, I'll just read Brian's comments from earlier. He made a comment that floor cooling temperature has to be controlled above the dew point. So you need a different temperature for floor than the coil.
Absolutely.
Past that, I'm going to give a shout out to everybody in the chat that has been quite engaging. We really appreciate when we get the engagement in the chat. We love questions. So I want to just appreciate everybody who's done that in the chat. Thanks for listening for the whole entire session. Thank you to our panelists and our experts. Each one of you guys have been fantastic today. I really appreciate that. For everybody listening in still, we have Michael Riddler's presentation on residential heating and cooling starting in less than a minute. So I hope to see each and every one of you guys there. And again, thank you very much.
All right. Thank you.
Thank you, everyone.
Everybody.